Exercise 4.2 up to question number 8, we have done it in exercise 4.2 part 1. Now in this part 2, we are doing the rest of the questions starting from question number 9. Integrate dx over a plus under root bx plus c. Now this directly we cannot say anything about this integral, that how we are going to solve it, but let's some easier substitution in it so that we can get a simplified form and we can easily integrate it. I just want to skip this under root. If I skip this under root, then we can get a simpler function as well. For skipping this under root, we need a square function inside. So let's suppose that bx plus c is equals to t square, so that we can easily get cancel with the under root and we get a simple function here. So I let bx plus c is equals to t square. Differentiate the both sides. We will get b is a constant coefficient, x will give us dx, c will give us 0, t square will be 2t dt. So dx is equals to, because we need the value of dx here, dx will be equals to 2t over b dt. Just replace these values in this function. In place of dx, we will write 2t over b dt, a plus under root t square. This square and under root will be cancelled, and this 2 over b is a constant. I have taken it outside. We got t over a plus t dt. Now both the t have the same power in the fraction form. This is an improper fraction. The method for solving the improper fraction is to divide both the functions. But if you don't know how to divide the functions, algebraic functions, then we can follow another method. Just make the same denominator function in the numerator. I need plus a here. If I add a here, then I need to subtract a as well. Now I can separate these two things. Just separate it. I will write a plus t over a plus t, this one over this, minus a over a plus t. This will be cancelled and I will simply get 2 over b integration 1 minus a over a plus t. Separate the integral. A is a constant. This can be easily separated and I will get 1 over a plus t. Dt, integral dt will give us t. Now a plus t. If I take the derivative of a plus t, I will get 1. And you see we have 1 in the numerator. So this can be written as ln a plus t plus c. Now our starting function was in x, but we have our answer in t. So we need to replace this t in terms of x. What we let in the start, bx plus c is equals to t square. Just separate t from this. If I separate t from this, I will get square root bx plus c. So just replace t with this as under root bx plus c. So I will get this answer. Question number 10. Dx over 1 plus x square arc tangent of x. Arc tangent of x, arc sine of x, arc cos of x always give us inverse. So this can be written as tangent inverse of x. We know very well that tangent inverse of x has the derivative 1 over 1 plus x square. I can make this 1 over 1 plus x in the numerator using this 1 plus x square. I can move it like this in the numerator. So now this tangent inverse of x has the derivative in the numerator. So we can write it like ln tangent inverse of x plus c. Or you can also write it like arc tangent of x. Question number 11. Integration of sin x plus cos x divided by sin x minus cos of x dx. If I observe this denominator and I take the derivative of this denominator, I will observe that sin of x will have derivative cos of x minus cos of x will have the derivative minus sin of x. That is equals to cos of x plus sin of x. This is the same thing as present in the numerator. So this denominator has a derivative in numerator. We can write it like ln this denominator function directly plus constant of integration. Question number 12. integration of sine square root of x divided by square root of x. Due to this square root, I cannot say anything like how I am going to find its integration. So just let this square root equals to t. Take the derivative on both sides. This square root of x will give us the derivative 1 over 2 square root of x. Because square root of x is x raised to power 1 by 2. If I take its derivative, it will be power down power minus 1. That will be 1 by 2 x raised to power minus 1 by 2. That is 1 over 2 x raised to power 1 by 2, 1 over 2 under root x. So this is the derivative of under root x. T will give us the derivative dt. Now here we have dx over under root x. So just remain under root x, dx over under root x as it is here, and just move 2 on the other side. This will be 2 dt. Now replace the values. Under root x will give us t and dx over under root x will give us 2 dt. Move the 2 outside. This is a constant. We get sine t dt. Sine of t integration is minus cos of t. So we will get minus 2 cos of t. Now we can replace back t as under root x. So we will get minus 2 cos under root of x plus c. Question number 13 says we have to find integration of under root e raised to power 2x plus e raised to power 3x. E raised to power 2x, e raised to power 3x. E raised to power 3x can be written as like this. E raised to power 2x into e raised to power x, because if we multiply them, powers will be added. So we can take e raised to power 2x common out of this whole function like this. So we will be left behind 1 plus e raised to power x. This is a square function. This was a square function. It can be taken outside the square root and we will be left behind e raised to power x, and inside the function is 1 plus e raised to power x. This can be written as in power 1 by 2. Now you see, if I take the derivative of this function, I will have e raised to power x, and that is already present here in the multiplication form. So if we have it in multiplication form, the derivative, then we can add in the main function the power with 1 and also dividing it with that power plus 1. Just simplify this power, we'll get 1 plus e raised to power x 3 by 2 over 3 by 2. This will be moved up 2 by 3 and the same function as this. Question number 14. Find the integration of dx over e raised to power x plus e raised to power minus x. I am just letting e raised to power x equals to t. Take the derivative, we will get e raised to power x dx equals to dt. Now before replacing, I just need to simplify this function. I want to just eliminate this negative sign from here. I am taking e raised to power minus x common from here. If I take e raised to power minus x common, then divide, because this x e raised to power x has no e raised to power minus x, so just divide it with that function. Plus 1, because this e raised to power minus x is taken outside, so we will be left behind 1 here. Now move this e raised to power minus x up and we got e raised to power x. The power will become positive now. This will be e raised to power x into e raised to power x, because negative can be moved up and it will be made positive. So we get e raised to power 2x here plus 1. Now we can easily replace it. E raised to power x dx. This is equals to dt. So I have written dt. E raised to power 2x. E raised to power x is t. If I take the square on both sides, I will get e raised to power 2x equals to t square. So I get t square plus 1. We know very well that integration of 1 over t square plus 1 will be tangent inverse of t using the table of integral. T can be replaced back with e raised to power x. So the answer will come again back in x plus constant of integration. Question number 15. E raised to power 2x divided by under root e raised to power x minus 1. I can separate this e raised to power 2x separately like this, e raised to power x into e raised to power dx. I don't want this under root basically here, so I need to just replace or substitute it with some square function. So let e raised to power x minus 1 equals to t square. Take the derivative, we'll get back this function. Replace e raised to power x dx with 2t dt like this, and e raised to power x minus 1 under root will be replaced with t square. Now I need to know this value. This is left. What I can substitute here in place of e raised to power x? I can get its value from here. This will be e raised to power x equals to 1 plus t square. So replace it with this function. Now this under root will simplify this t square. We will get back t. This t will be cancelled with this t. 2 is taken outside. Now we will be left behind 1 plus t square. Its integration will be t plus t cube over 3. Replace t. Replace t. T we will get, take this under root on both sides. We will get t equals to, we have t square is equals to ex minus 1. So t will be equals to square root ex minus 1. And now we have need t cube here. So t cube will be e raised to power x minus 1 under root cube. This will be e raised to power x minus 1. This is 1 by 2. Under root is 1 by 2 into 3. So this will be e raised to power x minus 1, 3 by 2 plus constant of integration.